Okay, we're looking at the November 2017 grade 11 examination, and we're looking at the electricity question. This was highly requested by many of our grade 11 viewers. The circuit below consists of a 6 ohm and 15 ohm resistor in parallel and an unknown resistor R in series. An ammeter, a high resistance voltmeter, a closed switch, and battery are connected as shown. Resistance of the batteries and the wires can be ignored. The total power dissipated in the parallel part of the circuit is 50 watts. So they are telling us about the power in the parallel part of the circuit. So here's our parallel part of the circuit, and we've got the power here, 50 watts. Now, if they did not tell us that these were in parallel, we could still work that out. And how we do that is we always begin at the positive terminal of the battery. The longer line represents the positive terminal of the battery, and the shorter line represents the negative terminal of the battery. Now we know that current always flows from the positive terminal, and when the current leaves the battery, it is the total current that leaves the battery, and the total current is what flows through this ammeter. As the total current flows, it reaches this point, and at this point it has a choice. Some of the current flows through the 6 ohm, and some of the current continues downwards and flows through the 15 ohm resistor. And that is how we know that the 6 ohm and the 15 ohm are in parallel. When we see the split occurring, that indicates to us that resistors are in parallel. And when we have resistors in parallel, we can calculate their total resistance by using the formula 1 over R parallel is equal to 1 over R1 plus 1 over R2. And this equation is on our data sheet. That will give you your first mark, writing down the formula. So 1 over R parallel is equal to 1 over 6 plus 1 over 15. And when we put that into our calculator and solve, we would get an answer of 4,29 ohms for the resistance in parallel. And that was actually 10.1.2's question. Now, we were following the current here. We said that at this point here on the circuit, after passing through the ammeter, some current flows through the 6 ohm resistor, and some current comes downwards and flows through the 15 ohm. So a split occurred, and that indicated to us that the 6 ohm and the 15 ohm were in parallel. But whatever current goes through the 6 ohm and whatever current goes through the 15 ohm, they get together again at that point. And now the total current is back together. So the total current now flows upwards through resistor R. So resistor R gets total current, and then it returns back to the battery again. Total current. Now, a split does not occur here at the voltmeter because we know that voltmeters have very high resistance. And because they have such high resistance, no current or almost no current flows through them. That is why when the current flows, it flows straight through resistor R. No current goes to the voltmeter. The first question wanted us to define power. And to define power, we use the equation from our data sheet. Power equals W over delta T. And when we read this equation, it says that power is equal to the rate at which work is done. So power is equal to the rate at which work is done. 10.1.2 asks for the effective resistance of the parallel combination, and we worked it out by using our formula. They now want the potential difference, and another word for potential difference is voltage, V. The potential difference across the resistors in parallel. So if I want the potential difference across the resistors in parallel, I need to go to, I'm going to bring this down here now and work this out. 10.1.3. For the resistors in parallel, they already gave us the power. They said it was 50 watts. And we just calculated the resistance in parallel, and that was 4,29. And they are asking us to find V, the potential difference across resistors in parallel. So when I list each of these one below the other like that, and I link up these variables and go to the data sheet, we would find the equation P is equal to V squared over R. and that's going to help us to solve and find our unknown. A lot of learners ask, how do I know which equation to select? How do I know which equation to choose? And each question is so different. And that's true, each question is different, but what you need to do is read the information, interpret the information, and then list all your values. This is a very, very handy tip, because when you list your information, it's going to show you that we have power, we have RP, and we want V. And the equation from the data sheet is P equals V squared over R. So 50 is equal to V squared, and R parallel we calculated 4,29. And when we put that into our calculator, we get an answer of 14,64 volts. And that was the answer for 10.1.3. Now they ask us to calculate the current in resistor R. So we're going to go to our circuit and have a look again, and we saw that the total current flows to resistor R. So if I can find the total current, then I found the resistance through R. Remember, the current splits, some of it goes to 6 and some of it goes to 15. But together, the parallel combination receives the total current. So if I use my Ohm's law equation, R equals V over I, and if I use R parallel, V parallel, I parallel, we know R parallel is 4,29. The voltage across parallel we could calculated in the previous question, 14,64. It can give me I parallel. And I parallel comes out, when we put that into the calculator, as 3,41 amperes. So what this tells us is that here, whatever went to the 6 ohm and whatever current went to the 15 ohm, together that made up 3,41 ohms. So this current here is 3,41, and it flows through R 3,41, and that means that even this ammeter read 3,41 before the split occurred. The switch in the circuit is now opened. How will the reading on the voltmeter V be influenced? Choose from increase, decrease, or remain the same, and explain the answer to question 10.1.5. Okay, so going back to this diagram, I've just cleared it to make some space. They tell us that the switch in the circuit is open. So we're going to go back to the circuit and see exactly what happens to the current. We know that we always start from the positive terminal of the battery, and the total current flows through ammeter A. So that would be I total. And at this point, the split occurs. But if this switch is open, that means I now have an open circuit here. So nothing is going to flow through the 15 ohm. In fact, we can say that this part of the circuit does not even exist. Because remember, one of the requirements for a current to flow is it needs a closed path. And there's no closed path here. There's no path for that current to flow. So the current automatically flows through the 6 ohm. So now the 6 ohm gets total current as well. And whatever goes to the 6 ohm then flows through the R, through resistor R. So that tells us now that we have a series circuit. And we know that in a series circuit, the total resistance is higher than in a parallel circuit. And if total resistance increases, then total current decreases. And they wanted us to tell them what happens to the voltmeter reading, voltmeter V. So if I look here at voltmeter V, it's measuring the voltage across resistor R. Resistor R itself doesn't change. It's the total resistance of the circuit which changes. And by the total resistance of the circuit increasing, it causes the total current to decrease. So that means that the current that flows through R is now less. And if I use my equation, I'm just going to come here to the top. If I use the equation R is equal to V over I, and I rearrange this, then V equals IR. We said that R itself does not change, the resistor, so R is constant. So V is directly proportional to I. V is directly proportional to I when R is constant. So if I decreased, then V would also decrease. And that would be our answer. So we would say, how will the reading be influenced? We would say the reading decreases. And then explain the answer, we would just use this exact explanation that we just did here at the top. So the explanation was using this equation. So we would start with R is equal to V over I. V is directly proportional to I when R is constant. The current decreases, therefore the voltage also decreases. And that would be our final answer. I hope that you found this video beneficial. Please like and subscribe so that you don't miss future videos, and share this with as many of your friends as you can so that more people can benefit from these lessons.